Hey everyone, in this video we are going to take a look at my implementation of AI Scientist, which creates machine novel and original machine learning models and implements them, grounds them, and after running them, it saves the explanation, the code, and the metrics, whether it's an error message or an actual progress metric. Writes them to file, and we can actually see the progress happening in this HTML. We won't have the running of the code, gives an error, it'll go ahead and iterate on it. It's designed to come up with novel and innovative solutions. So we'll talk deeply about how this model works. I'll of course zoom in. This is kind of like the demo version. Here we go. Actually, the second run actually ran a model and returned some metrics. Okay, and when we get some metrics, they're displayed in the metrics section. Explanation. This web page automatically updates, plus the code, which you can review. We are also saving the solutions to the solutions folder. So we can actually get this running, so we can see how it works. I am actually limiting the process timeout to 15 seconds, so the code execution only at 15 seconds, and the AI scientist knows about that and tries to come up with a solution which can execute before the process times out. As you can see, in this case, we timed out, and it actually knows about it, and it will try to modify the script so we can run within the given time frame, so therefore you can have quicker iterations. By the way, the code files for this will be available at my Patreon, the Dark Technical. Link will be in the description, but we will talk about the code shortly. So this is actually trying to solve the data set that is presented in the Dataset Series 3, and it is trying to evaluate based on the evaluation. This data set, I created this data set to be multiplication problems, 1-digit and 2-digit multiplication problems, and the evaluation data set is 3-digit multiplication problems. So it is trying to create a model that actually fits to the dataset.csv, but should also try to generalize to 3-digit multiplication. So this is a difficult task if you ever dealt with neural networks. But essentially that's what he's trying to do. If there's a planning step, comes out with a name, a solution, and an explanation at the end for the solutions that it comes out with. We write the explanation to a TXT file so we can read it. These are also shown in the HTML page. And code that it wrote here, it wrote adaptive polynomial network, for example, and the metrics, if there is any, or if there is an error message, then we write them to a JSON file for better observability. So sometimes it is instructed to run it with multiprocessing, and I believe that actually creates an issue with the timeout process, which I am just realizing, but other than that, this works very well, and we kill this terminal. We can run this again, but they may increase the process time up to about 5 minutes, so we can have this running in the background, and we delete the solutions, and we'll begin from scratch. There we go. So this is a basic scientist. I will hope to probe on it when I just will direct a video on this, so you can get the basics straight as we make more videos on this topic, hopefully. So this is, I get inspired by the AI scientist paper, and I've actually looked at the GitHub, and I see that there is really no magic, but mostly very clever prompting and logic. That's what they're doing here. And this is about it. So let's begin by reviewing the code. So the terminal will be running in the background, but I'm just going to close it so we can actually see everything better here. As I said, the dataset I have generated with this generate dataset.py, which we'll take a look at, and also the evaluation set. And then we will take a look at the basic scientist, which is based on the unified.py file. So you can ignore the rest of the files. So before we begin reviewing the code, I'd like to mention that you can, if you're enjoying my videos, you can find all of them at my website in a convenient search bar. My website is ecolive.live. Link will be in the description. And if you are a patron, then download all my project files. You can find them here with this download code link. Okay, without further ado, let's dive into the code. So the multiplication dataset defines a range of numbers for 1- and 2-digit categories. We want to include all 1-digit and 2-digit multiplicatives. Combine those lists to all numbers, generate all possible combinations using iter tools, make it a list, shuffle them, and then pretty much open them and select all the combinations and multiply them and write them to file pretty much. This gives us this dataset CSV with number 1, number 2, and the result. And the next part is to generate the evaluation dataset. So we define the range of numbers for a 3-digit category. We create all combinations. We shuffle them, but we were writing them to eval.csv. We only take the first one number. So this is going to be an evaluation dataset. So this is not where generating our dataset. As you can see, our solutions are being generated in the background. You can see the process. I guess we already found error. It'll work on the fix set. And I also just fixed the multiprocessing error too. So now the basic scientist should run without any issues. So the requirements for this is OpenAI, Anthropic, Term, Color, Pydantic, and PS utils to control the multiprocessing processes. A lot of these are needed for the unified.py file. If you want, this is just a convenient way to talk to many models at the same time or processes. If you would like to know more about the Unify, you can watch this video, Unify API. I go into detail there. But we are using that to build the basic scientist. We will use subprocess to execute the code. And here we are importing the unified APIs from Unify. And at the beginning of our script, we are printing that the script will execute generated code. We agree to proceed because this did not execute in the code yet. Isolated environment, so it's something we should be aware of. Here we set the process timeout in seconds. So here I set it to 100 so we can follow the progress as we are going along. But you can set this as high as you like or as low as you like. The system message, well, for the agent will take this into consideration. Maybe you can keep it, for example, 300 for 5 minutes. This means that the model then generating the machine learning, well, it will take this into consideration. It'll try to create the iterations of the code which can actually execute within a given time frame. And also, if the code that it writes doesn't execute within this timeout, we just practically end it and let it know that this has happened. For example, it's currently and it's still executing. Perhaps it hasn't run into the timeout. So yeah, we try to control the iterations like this. We initialize unified APIs with Anthropic's 3.5 Sonic. This is to read the CSV files, the function. Then we read the dataset and eval into the variable series R-based system message. You are an AI scientist tasked with creating novel and original machine learning solutions for the problem presented in the dataset. So you don't insert any additional information other than the sample dataset. So Jared, if you wanted to apply this to a different problem that you're interested in, you could just create the datasets. This code will automatically sample it. Now, if you are sampling the first timelines, this will also include the labels. But if you wanted to include additional information about your dataset, feel free to include it here. So we are dividing the system message into our tasks to analyze the data, create novel methods, but implement solution including data processing, model creation, training, and evaluation. We do so say include print statements for adequate process metric throughout the code. Because since we're running subprocess, we will be taking the terminal outputs, whether it's an error or any kind of print message. So we are instructing it to write code that actually, perform some kind of progress report so that when it's done, we can see it here like this. And we can pass it on to the scientist in consecutive iterations. Ensure the code can be executed and will output results that can be analyzed for future improvements. We do say this, you can remove this if you like, ensuring we are asking it to actually use multiprocessing and threading so that it can actually speed up the trading process. So this must execute within 5 minutes. This shouldn't say action 5 minutes like that or process timeout seconds. Yeah, your algorithm to optimize your code to meet these constraints. Restrictions are, so here I have entered my laptop's specs, so it knows about it. So your solution will run on a gaming laptop with i5 CPU and RTX 350 GPU. Please take this into consideration, optimize the solution. And here we say use threading and multiprocessing to speed up your solution. And if you take a look at our CPU, we can see them being utilized or not. Sometimes they all fire up if the code that I scientist is generated is using proper multiprocessing methods. The entire execution of your solution was complete within this many seconds, which we have entered in the beginning, remember. And other than that, we are saying that, and we say planning. So return your solution. We should go up here is the following format: planning. Your planning goes here, design your unique and original solution here, pay special attention to how you'll use threading and multiprocessing to speed up your solution and ensure it completes within this many seconds of time limit. Then, this is a name which is going to be file friendly, it's file system friendly. So we can write them here, like for example, this is called bootstrap GD regressor, and that's what we are using as the name. The solution, the explanation, which we save into a TXT file so we can read it. This is also what we display in the web page. And explanation, remember to focus on originality, effectiveness, efficiency. You'll really modify the system message. So that's if you set the system message by formatting that string with all the variables. I would like to take a moment to talk about the benefits of becoming a patron. But some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration or iterate quickly. Another benefit is that you'll have access to all my courses. And the recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streetlit course and the REST API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. And here, Get AI Solution is going to take it iteration previous up of previous errors, previous timed up. If it's iteration 1, this is the user prompt which we're going to be using. Please provide a novel machine learning solution for the given dataset. Remember to create your own algorithms from scratch without using any pre-existing ML libraries. So if you noticed, we are not using any scikit-learn, SciPy, or Arch or TensorFlow or anything like that. Well, that's due to this. If you wanted to, a different approach, you can definitely modify it. And if it appears now in the first iteration, the second iteration message is going to include the previous output of previous errors. So the previous solution has been executed here. Are the results? We passing the output if there is any. Otherwise, we pass in the errors. The previous, if we read into a timeout, that's why we have a if statement here. This previous solution exceeded the time limit. Please optimize the code. Otherwise, we leave this empty, which means we don't need to insert anything because there wasn't a timeout with you. Based on these results, please analyze the performance and suggest improvements or a completely new approach for this iteration. Focus on reducing any errors, optimizing model's performance. Right? Remember to keep your social knowledge. Avoid using pre-existing ML libraries. And now we passed how it should return its response, similarly. And now we just use the unified check method, passing the user message. Now the rest of this is just to extract the proper parse the responses. This is to parse the name, the solution, explanation. Then once we had them, we save them to file. And here is the pipe that's going to execute the code. If that's not a 5-minute timeout, we can specify it any which way. So increase the solutions folder. If it doesn't exist, as you can see, we've created quite a lot of solutions even as we are making this video. Some errors are, at least some of them actually complete. And you can read the explanations for each one as well. So here it's using decision tree, simple ensemble. Very interesting, really. I would like to explore this more. Anyway, then here we use our process pop open Python to run the code. And we do output the cd out, is the error bit pipe, and some other parameters. We initialize basically the terminal out and error messages. It is to be set timeout to false at first. So while true, we read the lines of the terminal outputs from this particular process, and we try to print them. Sometimes this works, sometimes it doesn't. So it should. The point was that it should print the results here, but can actually isn't, maybe you can find a solution. But nevertheless, we use the thread to start this process. Target. Yeah, so this was just a function. And while the thread is alive, if we exit the timeout, we do use PSUtils here to get the process ID, the parent, and we terminate each child processes. This is what helps with multiprocessing. This will only happen if the timeout has reached. We terminate child processes because there can be threads and multi-processes, right, running, and I terminate the thread, join them, give it 2 seconds to clean up. Maybe we can give more time. We set timeout to true, and then we print, and then we trip the message. Sorry, we append the messages they city out, because that's what we're actually going to be writing as the metrics. So we find a timeout message, and if there's an error, we append it to a CDR. And when we're writing the metrics dictionary, we encode the CDR SCB error, timeout. So if you look at the metrics, you can include a terminal output, an error, or timed out message, which is all of which is passed through the model. And we save the metrics file name here. And here in the beginning, we were only saving the solution. And here we were receiving the explanation. And when the timeout actually is being passed, no, I'm not exactly sure. I kind of lost track of where the timeout was being applied, but it is applied somewhere over here. Oh, timeout, because we set the timeout, we're able to process timeout. Well, that's right. When we're joining the threads, that's when they use the timeout. So join takes in this timeout value. Anyway, here the main loop is going to start the iteration at 1, reset all variables, and while through we print iteration number, get AI solution. If there's no solution, we print something. Other than that, we print name, prints the solution, execute the solution, get any errors, print them, timeout, and assign everything to their variables so we can pass them into the get AI solution again, because it's a while. No. So that's it. Then we increase the iteration. So if you wanted to actually be asked to continue the each iteration, you can uncomment this. Okay. I just commented out, so it plays in auto mode. Yeah. So as you can see, we are getting some interesting results here. So this is how the scientist works. I hope you enjoyed it. I will go ahead and now show the terminal. Like I said, the code files for this will be available at my Patreon. Also, if you decide to become a Patreon member, that you'll have access to all my courses. Most importantly, the Causing Next Step Masterclass, in which I teach how to use Cursor to become really effective coders. I've been doing this for over 3,000 hours to create 300 projects. You can find at my website. And my patrons really love this. Each one of these zip files include a video of me building an entire project. Along with his code files, there's 17 of them now, or almost over 5 hours of material. Very useful if you're serious about getting into coding and using AI. Also, for my architect level patrons, we're here coding meetings every week. The next one is on the 25th, noon, Los Angeles time, this Sunday. Link will be in the description if you're interested in talking with me. And I do consulting. If you would to talk to me one-on-one, you can check out the higher tiers at my Patreon. So if you had any questions, we can work on them. I also have perks for my patrons. I have a deal with Monoflow, which offers $100 off from their over $200 price subscription. This is for architect-level patrons. They are actually backed by Y Combinator, automate long repetitive words that fits in tables. Check them out at monoflow.ai. I also have a perk from Boring Lounge, which they will submit your AI startup's website to 100-plus platform in 7 days. They're offering $70 off for architect patrons. This is for connoisseur patrons. I have Ninja AI, actually. So offering $10 off from their expert plan. So Nietzsche Chat is pretty cool. It's A-plus apps in one place, 6 premium chat, plus including image generator, music generator. So, but I'm not affiliated with any one of them. They just want to offer these deals for my patrons. If you're interested in, and if you do become a patron, you'll get those deals. Lastly, I've started Echo Hive Hackathon, which is at the end of this month. This is available for Architect Plus patrons. The prizes are, first place will get a one-hour one-on-one meeting with me. You sell your $50 in value. Second and third place get $75. But all top 5 projects will be demoed during a YouTube live stream, and the owner's GitHub link will be shared in the live stream. So if you're a patron or want to enter the hackathon, link will be in the description. So thank you for watching. This was the AI Scientist. I hope you will want this. See you in the next video.